A function in JavaScript is really a specialized kind of object. And since functions are objects, they can have properties and methods just like any other object. In this module, we'll first understand the different ways in which a function can be created and how the context is set in each of those cases. Then we'll look at the call and apply methods and how they allow you to indirectly invoke a function as if it were a method of some other object. Next, we'll look at how the bind method lets us bind a function to an object and return a copy of another function. Finally, we'll look at some of JavaScript's built-in functions. These include eval, parselnt, parsefloat, escape, and unescape. By the end of this module, you'll feel comfortable understanding when to use the call, apply, and bind methods and what benefits the built-in JavaScript functions provide. Let's begin. Before we look at the call function, let's review the different ways in which we can create a function and how does that affect the value of the this object. Here's a function we have seen in the previous module. We're simply printing the string hi and the value of this to the console. In the previous module, we learned that every JavaScript function, while executing, has a reference to its current execution context through the this keyword. So what would be the value of this here? As expected, it refers to the global window object. Now here's another example. This time, we declare a greeting variable and assign an empty object to it. Then we define a property sayHi whose value is an anonymous function. Its body is the same as that of the earlier function. Now the value of this is no longer the global window object because the execution context in this function is different. The value of this now refers to the object referenced by the greeting variable. Let's look at yet another way a function is created in JavaScript. This time we are using the new keyword when invoking the sayHi function. This is also known as the constructor function. The value of this here will be an empty object. Anytime you invoke a function with the new keyword, JavaScript implicitly creates an empty object within the function before returning it. So in our example, the variable greeting will hold this empty object. So now that we have a good understanding of how this object gets its value, let's look at the call method. In this example, we have two objects with properties name and age assigned to the variables person1 and person2. Next, we have a function expression sayHi that prints the string hi followed by the value stored in the this.name. We know that calling the function sayHi just prints hi, as this refers to the global window object, which does not have a name property. What we really want here is to set the value of this to something other than the current execution context. Every JavaScript function object has a few properties that come out of the box. One of these properties is the call method, and you can pass another object as an argument to this call method, as can be seen right here. Passing the person1 object to the call method as an argument of sayHi binds the value of this in sayHi to the person object, and this time the string hi John gets printed to the console. In the same way, when we pass person2, the value hi Mary is printed to the console. You can also pass additional arguments to the call method. Here, we are passing a message variable in addition to the person1 object. Call lets you run the function sayHi in the context of the first argument message. Let's see this in action in our demo. In this example, as expected, we get hi John and hi Mary in the console. Let's comment both our call methods and just run the sayHi function. Save the file, and the string hi is printed to the console, as the window object doesn't really have a property called name. Another thing to note here is that calling the sayHi.call method without any arguments is the same as calling the sayHi function. Also, you can only invoke the call method on another function. Calling person1.call will result in a type error as person1 is not a function. Just like call, every function object also has an apply method. In the examples we have seen so far, you can easily replace a call with an apply method. How does an apply then differ from a call? While the apply method syntax looks almost identical to that of a call, call accepts an argument list, while apply accepts a single array of arguments. We have an introduction function that takes in two parameters and prints out a message. First, we call the introduction function with the arguments John and student. Next, we call the same function once with apply and then with the call method. Note that the apply method takes in an array as the argument, while the call method takes a list of arguments. We are not really changing the function context of this value here, so we just pass undefined as the first argument. So how do we decide when to use a call or an apply? Use the apply method when the input parameter is already in the form of an array consisting of similar values. Otherwise, if you're dealing with multiple arguments that are not really related to each other, use the call method. Let's see this in action. This is our example from earlier. We define the introduction function and invoke it in three different ways. Note that we pass the input in the form of an array to apply, whereas call accepts all the input as separate arguments. The output of all the three functions is printed to the console. With call and apply, we call an existing function and change the function context, that is the value of the this object. But what if we would like to make a copy of a function and then change the value of this? The bind method allows us to do just that. Here we have a person1 object with the name property set to Mary and a getName function that just returns the value in name. Next, we have another person2 object with the name property set to John. When we call bind on the person1.getName function and pass the person2 object as an argument, a new function is created and returned and assigned to the getName copy variable. Additionally, the value of this in the new function is set to the person2 object. Therefore, when we print the output of the getName copy method call, it returns John. In this way, we are no longer changing the context of an existing function the way we did in call and apply, but instead create a new copy of a function and then change its context to another object. Let's look at the bind method in our demo. Again, this is our example from earlier. If we save, the output from invoking the getName copy function, John, is printed to the console. If we just print getName copy, it prints the body of the anonymous function to the console. Note, however, that this is a copy of the getName function in person1. Next, we look at some of the built-in JavaScript functions. JavaScript has several functions built into the language. In this module, we look at what they are and how to use them. We begin with the eval function. Eval, as its name suggests, accepts a string as input, evaluates it, and returns a value. We have two variables x and y, initialized to the values 1 and 2 respectively. Next, we print the output of the eval function that takes an expression in string format as input. The value 4 is printed to the console. In this example, we declare an additional string variable s with value abc. If you try to evaluate the expression x plus y plus s, the string value 3abc is displayed in the console. Therefore, when JavaScript comes across a string value abc, it concatenates that value with the number 3 and returns a string value. The function parselnt parses a string and returns an integer. Optionally, you can also specify an additional base or radix argument to return an integer of that base. If the first argument cannot be converted to a number, then parselnt returns the special value of nan, not a number. Here, both the statements print 15 to the console. The first statement returns the value f in base 16, while the second statement returns the value of 15 in decimal, which is also 15. The third statement returns a not a number. Parsefloat works just like parselnt, but it returns a floating point number. The first two statements here return 3.99 and 39.9 respectively, and we get not a number for the third statement, as an empty string cannot be passed to a floating point number. Escape returns the hexadecimal encoding of an argument in the ISO Latin 1 character set. For example, alphanumeric characters like a text is text in this character set, while non-alphanumeric characters are represented as %xx, where XX is a hexadecimal encoding of the ASCII character in the ISO Latin 1 character set. Unescape does the opposite of escape. It returns the ASCII string for a given input value. Let's run these functions in our demo. This is our eval function. If we save the file, the expression x plus y plus 1 is evaluated first, and then 4 is printed to the console. When we declare another variable s with the value abc and pass the string x plus y plus s to the console, the numbers are added first and then concatenated with the string abc, printing 3 abc to the console. Here we are printing the output of 3 separate calls to parselnt. Each parselnt function takes 2 arguments, a string and the base the value needs to be parsed to. If only the value is provided, the decimal base is assumed. So we get not a number for the value f and 15 for the value 15. Again, we are printing the output of 3 separate calls to parsefloat here to the console. And if the input is invalid, the output in the console is not a number. Finally, we are making 3 calls to escape, followed by 3 calls to unescape, and the output is displayed in the console. We use the output from the escape statements as the input for the unescape statements. This shows us how encoding and decoding works. This brings us to the end of the module. Let's review what we covered in this module. We began with how and when to use the apply and call methods, how they differ from each other, and how they let us change the context to another object. We also looked at how the bind function lets us create a copy of a function and then change the function context. Finally, we looked at some of the built-in functions in JavaScript and when to use them. In the next module, we look at the spread and rest parameters.